Now in the last lesson we looked at this idea of creating scientific notation from very large numbers. And we looked at this idea of taking a digit and multiplying it by 10 to the power something. However, not all numbers are this simple. Some numbers don't just start with a 3 and have loads of zeros after them. How would we write something like 46,000 or even 46,252? Things like that are a bit more complicated, but it's really not that hard to do. So let's look at this idea, 3,200. That equals 32 times 100, which is 32 times 10 squared. Now, what we try to do in scientific notation is keep the first number as small as we can, and the way to do that is we try to keep the first number here, I'll just highlight it, between 1 and 10. Now, in order to do that, in this case we couldn't use 32, because 32 is obviously not between 1 and 10. So the way we do this is we insert a decimal point to make this first bit, not the zeros, just this first bit be between 1 and 10. So the only way to do that is to put the decimal point between the 3 and the 2, and then we can think what we'd multiply it by to get 3,200, and that would be 1,000, because if the point started here, then it would need to jump 1, 2, 3 places to get to the end of the number, which is the same as multiplying by 1,000. So let's shorten this down to scientific notation. So it would be 3.2 times 10, and 1,000 would mean 10 to the power 3. And that is it for scientific notation. If we can do that to all our numbers, get the first number between 1 and 10, always do times 10 to the power of something, and think how many decimal places or points, it's how many places the decimal point has to jump to get to the end of the number. We can do this. So here's the kind of way to do it. So change into standard form or scientific notation the rules. So move the decimal point till it comes after the first digit. So basically you're looking at these first numbers here and creating a number between 1 and 10. Just move the decimal point after the first digit, do that. So we've got 3.45. The next thing you want to do is you want to see how many places the decimal point moves to get to the end of the number. In this case 1, 2, 3, 4, 5. Or you can start at the end and go to the front, but it's 5 jumps. And all that is that's your power. So it's always got times 10, and then the power is the number of jumps the decimal point has to make. Well, if you're interested in a bit of music, it's quite easy to do. Okay, I'll stop that. Right, so let's have a look again at the questions we had about distances between planets. And let's see if we can write this in scientific notation. So here's a big long number. Let's try and write it in a short way. So the first thing you have to do is you have to look at the 77 part and create a number with this that's between 1 and 10. Now the instructions before said move the decimal point after the first digit, so that would be here, so that would become 7.7. We've always got times 10 to the power of, and if we think how many jumps the decimal point needs to make to get to the end of the number, it's going to be 1, 2, 3, 4, 5, 6, 7. Hence your power is 7. So this can be written as 7.7 times 10 to the power of 7. Okay, 2 more examples. Let's look at this first bit. We need to create a number between 1 and 10. So put a decimal point after the first digit, so 1.517 times 10. And then let's have a look at how many jumps the decimal point is going to make. So it's starting here, because after the 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. To be really accurate with this, to get it correct, but 9 jumps to get to the end of the number. Okay, last one. So there's your first bit here. So it's going to be decimal point in here, times 10, and let's have a look at how many jumps. So, oops, decimal point goes in here. I'll do that again. Right, change it to blue. There we go. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can rewrite this 1,747,200,000 kilometres as 1.7472 times 10 to the power 9 kilometres.